So hello friends, welcome to my channel MN Coaching Center. So today I'm going to explain your 11th standards physics second chapter, that is units and measurements. So let's come to the introduction of this chapter. So as you all know, measurement of any physical quantity or comparison with a certain basics quantity or comparison with the international accepted reference standard called unit, comparison with units, and the result of the measurement is the physical quantity is expressed in the number of numerical measures. In the numerical measures, the physical quantity we express, as you know. And also the large, very large unit and limited number of units for express physical units, since they are inherited with one another. They are, and the units fundamental or basic quantities are called as fundamental or basic units. The first basic units or basic or fundamental quantities are called as fundamental and basics or basic unit, and the units of all other physical quantities can be expressed in such an combination of the basic units. Such units obtained for the derived quantity are called as derived unit, that we can derive or called as derived unit. And a complete set of these units are called as the system of unit. The complete set of derived or both the base units, or it is called as the system of units. So let's know about the international system of unit. What are the international system of units? So there are three international system of units, that is CGS, that are used to express the centimeter, grams, seconds, and that for this it is used, and FPS, that are used to for foot, pound, seconds, how much seconds. And the another one is MKS, that is used for derivation of meter, kilogram, and second, and respectively, and other things it is used to represent. So let's so these are three units you have to remember. They may ask in your final exams. So these are the three units that are used, and the SI unit or the systems of unit, the standard of scheme of symbols, units, observation, many things are used to measure. While measuring we use many things. So there are many techniques, industry and commercial works, because SI unit used decimal system conversion within the system of simple conventional. We use decimal system, and the SI unit in this book, in the books we can see the SI units in the many books, physics books you can see. So here they have given the diagram. So here diagram has the theta. As you know, theta in max you have learnt, theta that has ds by r radians, and it has dA by r radian r square steradian, that has second circle. And also because of these seven base units, the seven base units here we can see, that is the length, mass, time, electric current, thermodynamic, temperature, or the amount of substance, luminous intensity. These are the so there are seven units, that are length, mass, time, electric current, thermodynamic, amount of substance, and luminous unit. And their length is measured by meters, mass is measured by kilogram, time is measured by second, and electric current is measured by ampere, and thermodynamic is measured by Kelvin, and amount of substance is measured by mole, and the luminous intensity is measured by candela. So these you have to remember the maths and final exams, how we can measure the electric current, that is ampere, or thermodynamic, that is Kelvin, or amount of substances, that is mole. This they may ask in your final exam, so remember this. And here they have given the symbols of some length, and what is the SI unit of that they have given. So let's you read this photo. And also, so we employ some physical quantities that can be derived in seven basic units. That seven basic units, these are the seven basic units. So given special names, somehow some of SI units makes the units special names, and the seven base units, these are given in appendix 6.2 and 6.3. They have given for your ready reference. and other units they are given in 2.2 table. Here you can see up. So the measurement of length, how to measurement of length. So you are already familiar with the different methods of measurement of length. For example, meter scale, that is 10 is to 10 is to my 10 by root my 10 is to minus 3 meter to 10 to the power 2, 10 to the power minus 3 meter to 10 to the power 2 meter we can measure, and many other they have given. As you all are familiar to measurement of length in your lower classes you have learned, and measurement of large distance. So large distance such as the distance of a planet. Oh, so large distance such as the distance of planet or a star from the earth can be measured by a direct meter scale. So an important method such cases is the parallax method that we call to measure the distance of planet from earth. We to measure that we call parallax method to measure that. And also when you uh, when you hold a pencil in your hand against some specific point on the background, and look at the pencil first through a left eye A and then look at the pencil from the second eye B, so you would notice that the position of the pencil seems to be changed for you from the point of fall. This is because of parallax. The distance between the 2 points are observed is called as basis. The distance that we observe is called as basics, and the parallax angle, the angle that we get is parallax angle. And also, so let's come to the next one, that is they have given here some. So they have given that calculate the angle of 1 degree into 1 minute and the 1 second radius up to 360 square. 360 is equal to 2x radius, 1 degree is equal to 60, and 1 minute is equal to 60. So let's take as here they have solved the question, they have solved these questions. So this also you try and practice in your home by using so I will explain this. We have 360 degrees is equal to 2 pi radius, so pi is equal to 1 by 80, pi by 1 by 80 is equal to 1.74 into 10 to the power minus 2 radius we get. And when we get 1 is to power is equal to 60 is equal to 1.75 into 10 to the power minus 2 the radius we get in first sum. When we solve it, we get 2.9 into 10 to the power minus 4 radius, and 2.908 into 10 to the power 4 radius. When we minus with 60, or when we do multiplication with 60, we get 4.85 into 10 to the power minus 6 radius. Like this you solve all the other problems they have given. It may be like a practice for you. So next topic that is we are going to learn is estimating of very small distance size of molecule. So the measurement of very small size like a molecule is we can measure as 10 to the power minus 8 to 10 to the power minus 10 meter. So we have adopted that special method. We cannot use a screw gauge or similar instruments we cannot use. So even a microscope has certain limitations. We cannot use microscope or opticals to investigate. So as light of the wave like features, resolution of optical microscope can be used for to see the wavelength of the light. Optical microscope is used, as you know. So for a visual light of range of wavelength is from about to 408 to 7000 4000 A to 7000 A. That is 1 angstrom to 1 A is equal to 10 to the power minus 10 meter square. Hence the optical microscope cannot be resolve the particle with sizes smaller than this. So smaller than this we cannot see the sizes, and also the smaller than this size we cannot see. Electrons beams the can be focused on the properly designed electric and magnetic field, and almost we will learn this all in our 12th standard. And a simple method of estimating the molecule size of oleic acid is given below. Oleic acid is the soap liquid that we use that has large molecule substance in order of 10 to the power minus 9 meter is its molecule length, we can say. And like that only they have explained that. And the volume of n dropped of solution is equal to nv centimeter square. So initially we determine the approximate volume. So and also amount of oleic acid in the solution we have to find, means n is equal to 1 by 20 into 20. So it is 20 into 20 is the oleic acid centimeter. So 20 into 20 when we solve, t is equal to, we get n by v 20 into 20 a centimeter square, that is the 10 is to power minus 8 meter. When we solve this we get. So next is range of length. So the size of the object we can across the universe in whole world is, we can see the size of the order is 10 minus 14 meter of the tiny nucleus. The size of order to 10 minus 14 meter is the size in which we can see in whole universe. So 1 fermina is equals to 1 is equal to f is equal to 10 minus 18 meters, and 1 angstrom, this they may ask, or it is like a general knowledge for you. 10 minus 20 meters, sorry, 10 minus 10 is to the power of minus 10 meters, and 1 astronautical unit is equal to 1 AU, that is equal to 1.496 into 10 to the power 11 meters, and 1 light year, the light year is equal to 9.46 into 10 to the power 15 meters. So this you have to remember. This they may ask in your questions, they may ask to solve the questions in the upcoming next things. So for that it may help, or it is like a general knowledge, so keep it, remember, nothing will happen. There is no loss on there is no loss for you if you remember. It is like a general knowledge. So 1 parsec is equal to 3.08 into 10 to the power 18 meters, sorry, 16 meters. So measurement of mass. So how to measure the mass? So mass is a basic property of matter, as you know. Mass is a matter, its basic property, as you know. It does not depends on the temperature, pressure, location, or the space wherever it is. It does not depends. And the SI unit of mass is kilogram. There you learnt in the 7th fundamental, right? Mass is equal to kilo, mass or weight is equal to kilogram, we say. And also, and the international standard kilograms apply to international Burana weight of measure. So this is BIPM, we call it as, to measurement weights and measurements laboratory, or available in many other laboratory also, it is there. And while dealing with atoms and molecules, the kilogram innocent units, in these cases there are important standard unit of mass, it is, and the unified atomic mass unit. The first is unified atomic mass unit, that is equal to, which has been estimated for expressing the mass of atom as, it is used to express the 1u, let's take as 1u, or 1 unified atom of mass unit, let us take as like that. So therefore 1 by 12 we can take. So 1 is to 12 we can take as 1 as atom, and 12 as carbon we can take like that. So therefore when we solve it isotope, 1 is to 6 into 6 into 10 to the power minus 27 kgs we can take it. So more you will learn in your gravitation chapter, that is 8th chapter. So I will explain that chapter also. So range of mass. So the masses of the objects we can across the universe vary over very wide range. There may be very difference in the mass of one object and another object, and vary due to time. So here they have given the range and order of the length of some masses, and in here also they have given the range and order of the some other masses. So measurement of time. So how we can time measure? So we can measure the time due to atomic standard of unit, or Indian standard of time. Here we say measure, not here we say IST, Indian standard time, that you have learnt in your geography. Like that only they call it as atomic standard of time, which is based on the periodic vibration, and that is, this is basically of Sismas clock or atomic clock we call. So such a standard time are available in many laboratories, and as you know, the seconds is taken as the time needed for 9.192,631.770 vibrations of radiance. The vibration, how it happens in the radiance, they are taken, and the balance wheel regulation of ordinary crystal, and the vibration of The vibration of small quartz crystal regulates the quantum crystal. So you have seen the old age, they were seeing the sun, and there was a sand clock there where they were knowing time when the sand was falling, that they were seeing when full sand fall 1 hour, like that they were seeing at that time. So like that now they have seeing that time like this by the seconds. The national standard of time interval seconds as well as frequency of the maintained through four seismic atomic clocks. Through four seismic atomic clocks they manage, and National Physical Laboratory NPL in New Delhi maintain the Indian, and it maintain the Indian standard of time, that is IST. In our country, NPS has the responsibility of maintenance and improvement on physical standard and the frequency of IST, that is Indian Standard Time, that is linked to atomic clocks. Also, it is linked, and the efficient seismic clocks are also it is linked. They are saying, and also the impulse that are gained over time by such a device is less than 1 part of 10 to the 13 the power we get, and they lose or gain no more than 3 us in 1 year. They lose or gain, and in view of tremendous accuracy in time measurement, the SI of length has been expressed in terms path length. Light travels in the certain interval of time the light travels, as you all know. So next topic, let's learn about accuracy, precision, and instruments and errors in measurement. So measurement is the foundation of all the experiments, science, technology. The results of the measurement can be measured with an instrument that contains some uncertainty. This uncertainty, there may be some mistakes or some small wrong things that may is called as error. So every calculated quantity which is based on measurement units, measured values, also has an error. So we shall distinguish between two terms called accuracy and precision. So the measure of how closely the measured values or the true values are there, how closely the measured values are there, that is called as accuracy. And the particular value that we get when the partition of true value, when both the particular value and true value both when it joins the value, the result we get, it is called as precision. When a true value and a particular value that we get, and when a true value both mix with each other, and the result we get, that is called as the precision. And so the three in an one experiment using a measuring instrument of resolution 0.1 centimeter, measured value found to be 3.5 meters. So which is another experiment using the measurement of resolution of 0.01, and the length we get is the 3.38. The first measurement has more accuracy because it has 3.35, means it is very near to 3.50 or 5, how much it can be we can say. But here it is near 3.5 is very much near accuracy, means the nearly measurement we are getting. But here 3.38 means little bit, not more near, but it is little bit far now. So 3.5 is very much near, so that is the nearest value we can say for the equation or the some whatever. So these are the ranges and order in the time intervals they are given. So systematic error, so there are errors either positive or negative they may be. So instrumental error, so that arises from the error due to imperfect design or some measurement instrument. Zero error in the instrument may come, etc., maybe come in that instrument, so that is the instrumental error. And imperfection of experimental techniques or procedure, so there may be determined the temperature of human body. The thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature it will give. So other actual conditions in the temperature, humid during the experimental systematic affect the measurement there may be. And personal error, that arises due to an individual bias, lack of proper settings of the apparatus, or if some personal mistakes or some small mistakes, the personal error can be happened. And next is random error. So random error, so It is the error which occurs irregular and hence the random with respect to sign or size. These can arise due to random and unpredicted fluctuation in experiment condition or any wrong error, some mistake random error. So least count error, so there may be least count error, there may be mistake in counting of smaller value, and due to that the error may occur in the time or accuracy, we can say. So here in errors I will stop. I will explain the next topic in my next video. So till here you understand, I think so like the video, comment on my video and subscribe my channel. I'm in coaching center for more video. I will explain the other topics in my next video. So till then, take care, have a nice day, bye friends, and share my video with your friends also. So okay friends, bye, see you, take care, I will see you in my next video. Till then, take care and have a nice day friends, bye.